Lesson 1.4, sketching graphs of functions. There's not a lot of new material in this lesson, so the video is not too long. Given any function f at x, we remember that we have all these transformations that we learned in grade 11, a, k, d, and c. So this is function using function notation. Remember that a, k, d, and c are real numbers. That's element of real numbers. And there's different ways to graph, and you've learned different ways to graph, and some of you are more comfortable with one way than another. I'm going to review a few of these method of graphing transformations today. So all the transformations that you see here are the same. The green one is the parent function for all these graphs. The green one is the parent function, and the transformed function is in red. Notice that the equation of each transformed function is exactly the same. They all have this equation in red here. So they've all had the exact same transformations. For the graphs that have a vertex, they all have the same transform vertex. So for example, our parabola, its vertex parent function is 0, 0, but the transformed one is 1, 3, and that comes from the d value and the c value here, right? These two give you the vertex. The absolute value has the same vertex. If you want to think of the reciprocal function, the intersection of the asymptotes. So if we drew the asymptotes here, the asymptotes would intersect also at 1, 3. It's not a vertex, but it's an intersection of asymptotes. We have a vertex on our radical function, 1, 3. So the d value and the c value transform all functions the same way. Those are horizontal and vertical shifts. The k value for all of them is a 0.5. That means all the parent graphs have been horizontally stretched by a factor of 2, and this is easiest to see here. So the parent sine wave is here, and we have a k value of 0.5, which is a horizontal stretch. They all have a horizontal stretch, but the sine wave is the easiest one for you to see how that's happened. This chart was taken from your textbook, so you're going to press pause here in a second. You're going to fill it all in because this is all review. The sine wave, the only thing here that's a bit challenging is when we talk about the sine wave, the intervals of increase and decrease. So as the sine wave, as you know, is a wave like this, so it has many intervals of increase and many intervals of decrease. And in section 1.3, I did a supplemental on how to do repeating patterns, how to define those here. If you don't remember the definition, what a turning point is, I've got it over here. So press pause now, and when you come back, I will show you the answers. All right, it's all filled in. So here are your answers for all of the different parent functions. They're all listed across the top and all the points here. So the only one that was maybe, the only one that some of you may see different, the way this is typed up here, this is a little different than what you may have put. Remember, you're using the formula for arithmetic sequence to do repeating patterns. So Tn equals a plus n minus 1d. That's how you define a repeating pattern. And then your a, you could put wherever the sine wave starts increasing. So here's our sine wave. So I'll just do both sides here, but we usually start on the first positive. So you could say that it starts, you could have said that it started increasing here. This is an interval of increase right here. Right, there's an interval of increase. If you use that one, then you used an a value. You use the a value of -90 for your a value. But if you chose to start down here, then you would have, I'll just put some marks in there, then you would have 270 as your a value. So these can be different. This form here is, this is factored. What you're seeing on the screen here is factored, and you may not have yours factored. So it could look a little different, but if you're confused with how to do that process, go back and review 1.3 supplemental. You don't need to know the parent functions to work with transformations. So for this question here, we've got an f in the question, but there's nothing telling us what f is. What is f? Is f a quadratic? Is our function a quadratic? Is our function a sinusoidal? There's nothing here telling me what my parent function is. I don't know what it is, but we can still do some work with this information here. So looking at A, K, D, and C, some of these can affect the domain and some of them can affect the range. Which ones? So the domain, not always, right? But the domain, let's start with that. We'll do the domain in red here. So the domain can be affected by K and D. Not always, because sometimes if you're starting with your domain is X is an element of real numbers, then it doesn't matter if your K value is a -3, like the one we have in this question here. A horizontal stretch or compression is not going to change the domain. For example, the sine wave. If we horizontally stretch or compress a sine wave, it's not going to change the domain. It's still going to be X is an element of real numbers. Same with the D value. The D value is a horizontal shift left or right. Think of the sine wave. That's not going to change the domain. It can if you were dealing with some other functions, like maybe the radical function. If we had something like this for the radical function, that domain can change. So not always. And how about the range? Which ones can affect the range? The range can be affected by the other two parameters. Range can be affected by A and C. Okay, so it just depends what your original range, if your original range was, say you had a line, just a linear equation, a linear function. You have a line like this, right? If you lift it up, if you lift it up 3 units, it's not going to change the range, or if you give it a vertical stretch or compression, it's not going to change the range. So it can change it, but not always. The next thing we're going to do with this is we're going to take a coordinate, -3, 4. We don't know what the original function was. Could be anything, but -3, 4 was on it, and we want to find out where it is now. Where has it landed after it's been transformed? So we're going to, the different types of mething, different types of graphing. One of them is a coordinate chart. So a coordinate chart just does each parameter at a time. Remember that K affects the X values. So we take all of our X's and we divide them by K. So we have an X value of -3. Sorry, we have it's -3 both. That's kind of a bad example. My X value is a -3. I'm dividing that by my K value, which is a -3. So my coordinate now, after applying that, the K value transformation is at 1, 4. Now we have an A value of -2. For the A value, we take our Y coordinate and we multiply it by A. So our Y coordinate was a 4. So we're taking 4 and we're multiplying by the A value, which is a -2. So our new coordinate, the only thing that's changed here is the Y value. So our Y value is now a -8. The A value doesn't change the X coordinate, so that's still a 1. The D is a horizontal shift left or right. So it's been shifted 5 units, and it was a -8. It was a 1. So 5 units added on to that is going to give me a 6. So we take our X coordinate and we add or subtract D. And the -8 is still a -8. The last transformation is a C value. The C value affects the Y's or the range, and we're going to add the C value. So our final coordinate is going to be 6, -7. So that's the coordinate chart, where we just do one transformation at a time in the chart. If we had several coordinates, we would do them all together. The other method is a coordinate equation. The coordinate equation, this is like a little mini equation here in the brackets. So what I've done, this is your x divided by k is here. Then you add or subtract your d, that's there. Y times a and y plus c are all here. So we basically just took that coordinate chart and we put it together to do all the calculations in a little coordinate form. The coordinate equation is good because it takes a coordinate and it keeps it in the coordinate form. So putting everything in place here, we have to do x divided by -3. That's the k value, and then we add on the d. So setting up the coordinate equation can be a little tricky, but if you're good at it, if you can quickly set it up, then it makes it pretty easy to sub in. So all I'm going to do now is I'm going to sub in my coordinate. My original coordinate was a -3, 4. So I put that in here. -3 is the x. I'm just subbing in, and my 4 was for y. So sub a 4 in here for y. And we do all the calculations. Okay, this gives me 1 plus 5 and -8 plus 1. 6, -7, which is of course the same thing I had up here, right? We get the same answer either way. Those are two of the methods for graphing that you can use. If you're not graphing, if you don't have a graph to use, you're not drawing a picture, but you're just coming up with equations, those are two ways to work on that. So your homework is section 1.4 in your textbook. You can find it on those pages. There's one textbook correction, and that's it. That's all I have to say today.